Hello student, in this video we will study about the chapter number 10, which is gases, and the main topic of the gases are like characteristic of gases, pressure, the gas law, ideal gas equation, and further applications of ideal gas equation, gases mixture and partial pressure, kinetic molecular theory of gases, and molecular effusion and diffusion, and real gases derivative from the ideal behavior. So these are the main topic in the chapter number 10. So let's start. What about the gases and their properties? So basically this picture shows that our earth is have covered on the gases, and the air, which is a mixture of several other gases in a very different composition, and majority of the major component of the air is nitrogen and oxygen gas, which is 78% and 20%, and the remaining are in small, very small rare quantities. So this is the air, which is a mixture of several gases. Let's see the properties of gases. About the properties of gases, gases have indefinite volume. It means it can expand and compress also in a different shape, and indefinite shape. So its gases do not have any shape, they can accommodate any shape, so it's completely indefinite, and volume and shape both are indefinite. They are compressible, means you can press them, and all gases mixture are homogeneous, means you cannot see except like smoke. Smoke is heterogeneous because it has carbon particles, but all the gases mixture are homogeneous. And gases versus vapors. So vapors are different than the gases. The gaseous state of a substance which is a liquid or solid under ordinary condition, so that is called vapors. So vapors means any gaseous state of a substance which is solid or liquid. So gaseous state of. So next is measurable properties of gases. What are the properties of gases? We can measure it, such as temperature. We can measure the temperature of gas, volume of gas, and amount, how much we have, and pressure also. So what is the pressure? Pressure is equal, the definition of a pressure is force per unit area. So you can say like pressure is equal to force per unit area. So this is the formula for pressure. P is equal to F upon A, where F is force and A is area, unit area, and the common units of pressure are millimeter Hg, or atmospheric pressure, which is short form is ATM. And 1 atmospheric pressure is equal to 760 millimeter Hg. So these two units are very important. You have to memorize this one, that and you will use these several times, several places. So 1 atmosphere pressure is equal to 760 millimeter Hg, and older unit was used as a torr, and 1 millimeter Hg is equal to 1 torr. So these two lines are very important, so you have to remember and memorize that 1 atmosphere is equal to 760 millimeter Hg, and 1 millimeter Hg is equal to 1 torr. So next is once again we will study about some more about the pressure. Pressure is atmospheric pressure. What is the meaning of atmospheric pressure? Pressure is the amount of force applied to an area, as we have seen in a previous slide, that pressure is equal to force upon area per unit area. So this is the formula for the pressure, and atmospheric pressure is the weight of air per unit area. So suppose if you draw a column from the earth till all the way up to air atmosphere, after this air is will be done on the earth, and what will be the dimension of the this column, which will be 1 meter by 1 meter, and long will be, it's all the way from zero earth surface to atmospheric limit. Then the air column cross section area will be 1 meter square, and mass will be 10,000. It's like a 10 is power 4 kilogram. So 1 2 3 4 10,000 kilograms. So now you can see how much atmospheric pressure is at 1 meter square, which is almost 10,000 kilogram of air we have pressure on at 1 meter square area. So basically this picture shows that our earth, we live at the bottom of the gaseous ocean. We are living basically in the ocean of air, and we have a lot of air pressure on our body every time, which is mostly balanced by our blood pressure. And another thing is this, the pressure of the earth atmosphere. This is also shows that every corner, this picture shows that this is earth, and this yellow part is the atmosphere of earth, where gravitational force applied, and all because of the gravitational force all the things come towards the earth, and this yellow portion is the total area of air. This is the atmosphere, and also aeroplane also move in our atmosphere. So 50 kilometer of air presses down on every square inch of our body with a force equal to the 15 lb bowling ball. So this is the force we experience every moment on our body, that 50 kilometer of air. So this limit from here to here is almost 50 kilometers. So 50 kilometers of air we are air is pressing our body every time, and how much pressure we are experiencing, that is 15 lb, like a one bowling ball pressure is experiencing. Next is how to measure the pressure, and that is it real pressure is there or not. So you can look one video about this one. I have here YouTube video, and this link is this one. So youtube.com, watch, you can try to look this video, and that video explain that if you have a drum, iron drum, and if you and the lid is closed, so air is inside and air is outside, and both the air have 1 atmospheric pressure, that is why it maintain its shape. But why are not we crushed by the pressure? And similarly our body is also like a drum, this drum, because we take a breathing inside, so air is also inside our body, so we have atmospheric pressure inside and outside both. And but what will happen if you will heat this pressure? If you will heat, so when this drum experience air inside and outside, and both side it have 1 atmospheric pressure, so it maintain its shape just like our body. And if you start heating this air, if you will drum, you will start heating, what will happen? Basically air will compress, and not compress, it will try to expand it, but there is no extra space for this one. And what will happen if you will cool down immediately? So compressed air will try to, hot air will try to get cold and compress, but outside pressure will be same compared to inside. That is why this drum will squeeze. So pressure inside less than the atmospheric pressure, and that has been shown in this video. So you can look at this YouTube video, which is you can understand how the atmospheric pressure work. And in the next video we will study about the how to measure this pressure in a different conditions.